Hi, this is Nathan Tintle. In this Learning Goal video, we'll talk about the relative risk using the good and bad perceptions dataset. In this dataset, 83% of people who received the good version of the question indicated they had had a positive year, compared to only 33% of people who received the bad version of the question. If we summarize the association, one way to do that is by taking the difference in those two numbers. 0.83 minus 0.33 is 0.5. So 0.5 is the difference in the proportions between the two groups. Since that is not zero, that is, there is a difference in the group proportions, this is preliminary evidence of an association. But there is an alternative. That alternative is the relative risk. The relative risk, instead of subtracting the two numbers, divides the two numbers. This indicates to us how many times greater the risk of an outcome is for one group compared to the other. So in this case, if we take 0.83 and divide by 0.33, we receive 2.49. What this means is that individuals are almost 2.5 times as likely to indicate a positive response when they're asked the good year question as opposed to the bad year question. A few words of caution. Relative risk is very popular in the media, especially in the medical realm. For example, you might hear something like this: your chances of dying while flying are 17 times higher than the risk of death from lightning. Should we stop flying? Well, not necessarily, because overall the chances of death by either cause are very low. In fact, it's 1 out of 7,230, that's 0.00014 for flying, and 1 out of 126,150 for lightning. That's a lot of zeros before the 8. Both of these overall chances of death from these causes are very small. The relative risk doesn't tell us that. It just tells us dying is 17 times as likely from flying as it is from lightning. So it's easy to use the relative risk to make emotional decisions. And thus, it's pretty appealing when you hear people talking about news stories and in the medical realm and other situations to use the relative risk. This doesn't mean the relative risk is all bad. It's just one way of looking at the data. And we need to make sure that when we're presenting data summaries, like the relative risk, that we make sure we present a more complete view. And we're arguing that when you talk about the relative risk, you should also give readers or the people you're talking to a sense of the overall magnitude of the proportions as well as their relative value. A couple of other points. By convention, most times when people compute the relative risk, they put the larger proportion on top so they get relative risks greater than 1. It's not always the case, but that's frequently the case. And finally, keep in mind, what does a relative risk of 1 mean? That means no association. If the proportions are exactly the same, you'll get a relative risk of 1.